Hi, so my name is Mike Williamson, and I work at Treasury Board in the cybersecurity group. And what I want to talk to you about today is maybe somewhat surprisingly, building for automation. So this topic actually comes out of work that we're doing with the Canadian Centre for Cybersecurity to replace something you may actually know about, which is the HTTPS Everywhere dashboard. This dashboard has been a useful project that's allowed departments to track the rollout of web encryption across their various properties and domains. But with the kind of release of the implementation guidance on email security from the Cyber Center and its incorporation into Treasury Board's sort of main policy in this area, which is the standard on email, we've ended up in a situation where essentially we have more than just the one HTTPS thing to track. And this is something that, getting into the actual code of this thing, we realized that this was not something the existing code base was going to be able to accommodate. So this has led us to a partnership with the Cyber Center and basically a plan to build a new thing, a new system that is more in line with our sort of collective aspirations in the security automation space. So the result is what you're looking at, which is Tracker. And you can see here that basically it's still tracking the same two kind of things fundamentally, that sort of web security stuff and the email configuration. But importantly, this system has been designed from the ground up with the assumption that it's going to need to track many more things than this in a really reliable and performant way. And so, like I said, the sort of the plumbing and infrastructure part of this stuff is sort of humming along. We have it doing the thing that it needs to do. And the job at hand that we're working on right now is to build a sort of a sane and intuitive user interface on top of all of this. So for both Tracker and I think HTTPS Everywhere before it, the goal ultimately is about making security visible. So much of security ends up kind of hanging on these like obscure settings or the kind of the consequences of like weird defaults and stuff like that are super important, but really just aren't necessarily intuitive or visible when you're setting up servers and doing the thing that you do. So in the spirit of kind of what gets measured gets done, the goal of these systems is really to gather data about how our systems are actually running and surface this stuff to the people that run them so they can do the right thing. As I mentioned, we're already sort of scanning and tracking certain things, gathering data in this space, and this allows us to make certain things visible. With the implementation guidance and sort of all the research that's gone into the HTTPS sort of IT pin, we actually have some surprisingly crunchy and well-defined sort of definition of good that those things together kind of constitute. And what we're able to do with that is then use that as a point of comparison for for all the settings that we're seeing and observing in these real world systems, right? So the core notion here is that, as we're doing this, we're able to also, introduce a notion of groups that's going to allow us to have like totals within groups and differences between groups. And so if you're thinking of like groups of domains that maybe someone like SSC or a department that has a specific portfolios of domains that they care about, this is a useful thing that can allow them to get some visibility into some of the stuff they care about. And importantly, because we're going out and constantly refreshing this data, there's sort of two things that fall out of that. One, it puts us in a position where we can answer these kind of arc of history style questions about trends. And the other thing is that any answers that we give based on this constantly refreshed data are essentially completely recalculated based on information that's essentially at most hours old. So all of this stuff together, we're already able to make a bunch of this visible and are hard at work doing so. But here's the thing. Security is huge, and there is so much more that we want to make visible. The thing, though, is that when we're starting to think about like making all the security stuff visible, you realize that essentially really important security information exists at every layer of the system. And the other thought that kind of occurs here is that a lot of this stuff is just not visible from the outside. And for us who has like this system that's based on kind of scanning from the outside, that's something that gives you pause a little bit. So if we want to dig deeper into this area and try to figure out what like kind of future versions of Tracker might be able to offer in terms of value, one of the things that you kind of start thinking about is any kind of analysis that we're going to provide is going to require some sort of data to base it on. And what follows from that is really the realization that we're going to have to go and find a way to represent every layer of the system as data. So this kind of led us to the question ultimately of like, is it possible? I mean, since we're going to be building Tracker anyway, we have to build it somehow. Is it possible to like build Tracker such that it could be easily analyzed? Could we build it in such a way that all that sort of behind the scenes stuff that wouldn't normally be kind of visible from the outside, could we make it visible? And, ultimately this is about sort of making these questions, the kind of questions that show up in security groups often, which is, hey, are we vulnerable to this? And making a system that is making it easy to answer that kind of question is sort of an important thing. So the underlying idea here then is that we could use Tracker as a testbed, and we have used it as a testbed for an approach that basically means that what we're trying to do here is transform everything into data. And this is basically where we've ended up. So in any of these moments where we're sort of looking to do something, we've reached for technologies that have allowed us to sort of treat this as a sort of as data and give us data. So what I want to do is kind of give you a bit of a tour and show you some of the stuff that we've learned along the way. So as a starting point, this is sort of a key place to start because this is sort of the beginning of our story, and this is like a core idea here. So we'll start with platform as data, and the idea of a platform is really this, fundamentally that anything that your application is going to need to run and do its job. And so this can be just like the plumbing and wiring needed to run your thing, run this application. But it also means, ensuring that any other sort of collaborative services, maybe a database, are going to be kind of up and running at the same time. So this is kind of what we mean by platform. And in the platform as data space, basically Kubernetes is kind of the 800-pound gorilla here. It's a hugely popular project. There's a lot of hype around it, and kind of deservedly so when you get into it. But it's not well understood, to be honest. And so to kind of dig in a little bit to sort of what specifically about Kubernetes is sort of deserving of some of this hype, I think what I would say, at least for our purposes, is that what it allows you to do fundamentally is that it gives you a data format that allows you to describe your system. Then what you're able to do here is you're able to give Kubernetes that system description, and it will execute it to create a running system. And then this last thought here is, I think, maybe a big deal for people who've worked in the sort of security and compliance space. Importantly, it ensures that the system never deviates from the description. So the mental model that you should have here is fundamentally that Kubernetes is an infinite loop, and it really is. It's called the reconciliation loop. Kubernetes is an infinite loop that exists to eliminate the difference between the reality of the running system and the system you've described in the configuration you gave it. This is a really powerful idea. So what does this description look like? Well, they've sort of built on top of this data format called YAML. And this is what it looks like. It's sort of designed to be, fairly human readable, at least for certain humans. So what you can see here is the highlighted line down at the bottom of the screen is indicating that there is a Docker image that Kubernetes should be pulling and running. And the highlighted line towards closer to the top is where it says replicas 2. That's telling Kubernetes that basically we want two copies of this application running at all times. So there's some interesting stuff that happens when you describe your systems in this way, in this YAML format. The first is, it's data. YAML's data. So you do get the data for analysis. But the other thing that is kind of interesting is that you get a bunch of operational benefits as well. So on the operational front, what this sort of means is you end up with kind of most of the stuff that we think of as kind of change management. All of that stuff sort of gets boiled down to just edits in these text files, right, that hold your data. So say a deployment ends up just being changing this line that specifies that that Kubernetes should be running image A, a quick edit mentioning that it should be running image B instead, and Kubernetes will do it. If you wanted to say rollback, you would just edit that line again, specifying that it's instead of image B, it should in fact be image A that's running. Either way, it's Kubernetes' job to eliminate the difference between this config and the running system. So on the analytical front, what we have is some other interesting stuff that's going on. So basically, if you were to put on your sort of network security hat and want to answer the question, like what ports is this application actually opening and sort of exposing to the internet? Well, you can go to GitHub and you could clone our entire project. And then at that point, you would have all of this entire system description, and that would all be data. What you could do is use these two command line tools, Customize and YQ, and you could sift through that data and get your answer. And that's ports 80 and 443. But interestingly, if you were to go and say use a port scanning program like Nmap and scan our actual running system over on Google Cloud, what you'd realize is that the only ports that are open over there are ports 80 and 443. Now, you could chalk that up to a coincidence, but we've actually really designed this to ensure that those two things are always in sync. And this is really kind of the underlying idea of Kubernetes anyway. So the whole idea here is we have gone and taken that initial Kubernetes infinite loop. So where Kubernetes exists to eliminate the difference between the running system and the config that it has, we've paired that infinite loop up with a second infinite loop that exists to eliminate the difference between the config that Kubernetes has and the config that's on GitHub. The result here is that any changes made on GitHub will flow directly through to the running system. And in doing so, this has meant that the config that exists on GitHub is the canonical place to go for answers of any kind about this system, because the system is simply a reflection of what's there on GitHub. So it could be that the full significance of this is really, not felt by anybody who's outside the security world, but within the security world, it's pretty common to be handed a months-old Visio diagram and asked to judge sort of important security properties about this system that is represented there. And I think anybody who's been in this situation has always wondered, is this in any way representative of reality? Well, this double loop setup, it really ensures that the description you have of the system and that system description on GitHub really is connected with the system as it's running. So these are some important ideas, and they're really powerful stuff. And I think that the key thing here is that the realization that these ideas are so powerful, in fact, that we would like them applied at the infrastructure layer as well. So what we've done is basically looked around and realized that Google has been very active in this space. They've realized also this power of this idea. And so what they've done is they've moved into the infrastructure as data space with a project called Config Connector. So Config Connector is essentially what it's doing is it's basically taking that same Kubernetes data format, and it is creating descriptions of, it's using that data format and creating descriptions of all of the various Google Cloud infrastructure and services. And then importantly, what it's doing is they've extended Kubernetes with something called an operator. So it knows how to act on these new data types. What this means is that then it's not just Kubernetes being able to act on our sort of application level stuff. What we've done by adopting Config Connector is really that we've taken that Kubernetes infinite loop and brought it to bear on managing our cloud infrastructure and eliminating the difference between our cloud config and the running infrastructure on the cloud. So that's all pretty abstract. So let's make this a little bit more concrete. So what you're looking at is, once again, YAML. And this is a description of a hosted SQL database. What you can see here is this is of data of a kind SQL instance. And so this is it's not a native Kubernetes type. This is one of these new data types that Config Connector is bringing to the Kubernetes world. So what we're able to do is describe all of the aspects of this database and then hand it to Kubernetes to action. So I want to spend a second kind of reflecting on what happens, all of the kind of the implications of getting a description of a system like this in YAML format, because it's pretty powerful. So if you were to get such a description and you're sort of evaluating it with your sort of business continuity hat on, you might ask the question, how long will it take to rebuild this system from scratch? If in the event of, say, some sort of catastrophic event? Well, essentially, I mean, you're handing this thing over to Google, and it's going to take however long, just however many processor cycles are involved with provisioning this infrastructure. So minutes. If you were to put on your policy hat and start asking questions about data residency, what you can do is actually you can just see right there in the config that this is going to end up in Google's Montreal data center, North America Northeast 1. With your operations hat on, you may ask questions about but are these being backed up somehow? Well, again, the config has the answer. You can just look and see that backup configuration enabled is true. And finally, for security, the famous question is, is it encrypted in transit? Well, it seems that require SSL is set to true, so this looks like that's good. And we know that all of Google's services use encryption at rest by default. So this whole thing is looking pretty good to me. So I think the key idea here is for those of us in security who are used to receiving system descriptions as Word documents, getting a system description in this data format is kind of interesting. First, it's actually probably representative of reality, right? Just by virtue of kind of being dual use. So if you think about it, because this description is not just created to sort of mollify some security person like me, it's actually created because it's doing real work for some operational person who's getting their job done. So they're needing to keep this up to date to ensure that the system is doing what they want. I just get to sort of look over it because I need to do some analysis of it. But I can count on the fact that this person, because it's actually being used somewhere, it's up to date. And importantly, what we can see just sort of skimming through this stuff is that YAML's actually pretty human readable. And that means that we can just do manual analysis with our eyeballs. And then, of course, because YAML's also machine readable, that means that whatever we get used to doing with our eyeballs, we can eventually just bake into some sort of automation and write it into code. And importantly, getting our system description like this in this data format means that our documentation suddenly becomes data, right? And what we can do here is we finally have this sort of double loop system where we can ensure that this description, this documentation that we have of the system is actually reflects reality, or I guess more to the point, the other way around. So these are sort of the two kind of key stops on this tour of everything as data. But there's a lot more stuff I want to dive into. We've specifically gone and sought out and learned technologies like Kubernetes and Config Connector that fit into this sort of everything as data model. And we've gotten a bunch of really cool benefits out of this, right? We've checked the box of like enabling that automated analysis that we were after. And we found a bunch of operational benefits that kind of fell out of this. And importantly, we've eliminated something that's kind of the bane of security teams everywhere, which is configuration drift. But if we want to go and get more data, and we do, what we can do is actually change the way, where we are actually doing the work, and that will get us a few more things. So I think probably everybody is pretty used to thinking of GitHub as a code hosting service. And we're certainly thinking of it that way too, especially in this model of like everything as data. If we can host all our data there, especially in a public repo, that means that any analysis that you want to do can be done without giving you any special behind the scenes access, which is a great security win. But it's not actually the code hosting part that I want to talk about. The thing that I think is super cool is GitHub, the platform. So what's interesting about GitHub as a platform is that it goes beyond code hosting in that it actually understands the stuff it's hosting. And importantly, beyond that, it actually understands and records all of the actions that are taken on the platform. And important in terms of supporting our little quest for everything as data, that means that what we can do is we can get all of this stuff as data through its API. So I want to start a quick little tour through the GitHub API and some of the possibilities there with languages. So languages, I think, are underappreciated for their impact on security. And you can see a little bit of this in Microsoft's there's an article that came out recently where Microsoft went on record kind of saying that C++ is no longer acceptable for writing mission critical software over there. That's a pretty striking statement, especially given how much mission critical C++ there is in the world. if you look around at some other languages, you can see JavaScript as of 2015 has built-in language-level SQL injection protection, which has largely eliminated this from the JavaScript world. Golang is super famous for their like minimalist deployments with tiny attack surface, and Rust is kind of making waves across the industry, being the language of choice for security and performance-sensitive projects like Amazon's Firecracker Micro VM and their BottleRocket container operating system. So if you're a security person and you're kind of in a situation where you've got a fair number of projects around you that are all on GitHub, and you're kind of wondering like what programming languages are being used in there, what you can do is you can turn to the GitHub API and you can run a query like this. And this will give you the list of languages for our tracker project. So the answer that you get back is this nice blob of JSON that somewhat surprisingly lists Dockerfile as a language. Who knew? But it also tells you that we're using Python and JavaScript. And there's more that you can get out of this thing. So if you look at dependencies are another important thing that we're, as security people, really interested in, because they matter a lot for security. Depending on who you talk to, dependencies actually make up 90 to 97% of a modern application. This is true because this is a ton of code that you didn't have to write, but you get to basically deliver all of that value by writing 3% of the code, right? This is insanely powerful, but it definitely has some implications for security. So one of the things that you can do is start asking GitHub about dependencies. And this is where you start getting a real appreciation for the fact that it really does understand what's going on in those repos. So you can see here that GitHub actually understands the different ways that people sort of itemize and articulate the dependencies for their project. GitHub understands them, and it will actually sift through these little dependency manifests and tell you what's in them. And so a query like this will give you that we have a pip file in our project. There's 23 dependencies in there total, and you can see the first two are bcrypt and Flask. So extending this idea that GitHub does actually understand this stuff, it will go a step further. It's not just that it can tell you the name of these dependencies, it knows the version of them too. And a step beyond that, they have a vulnerability database, and they'll go and look those things up in the vulnerability database for you and tell you about it with a query like this. So the day we ran that query was a good day. But since new vulnerabilities are discovered all the time, depending on when you run this, you can know that maybe we're going to be busy at work fixing some stuff. The other thing that's interesting is you can get a sense of workflow. Who's working on a project and how they're doing has some pretty obvious security implications, and we can get this information too. So peer review is kind of a big deal on projects, maybe less so in the early stages. But basically, you definitely want to do some thinking about like the code you're including and merging into your project. So a query like this is going to give you a sense of whether or not the peer review is being done on pull requests before they're merged. And in this case, you can see that we're doing it. But if you sift through, you'll realize that, when people are on vacation and stuff like that, an early stage project like ours, sometimes skips this step. If your project is sort of drifting, is considered anything close to like critical infrastructure, you may want to be a lot more stringent here. Finally, I think it's a kind of a neat thing to be able to realize that you can basically go and find unmaintained code like this. So if you sift through, you can find the date of the last commit. And this will tell you how old some of this code is and how long it's been since it's received some attention. So There's one final thing I want to touch on with GitHub. This is something that's really cool, but we really haven't touched any of our stuff, but it's definitely kind of caught our attention and is on the horizon. One of the things that's really hard to kind of get some sort of data representation of is your actual code. GitHub has actually solved this problem with a project called CodeQL. And what they've done is kind of incredible. They've created a new language that allows you to query your code directly with this sort of SQL style language. The concept here is that you import, whatever kind of language definitions the definitions for the language that you're using. And this gives you sort of the SQL-like interface that allows you to actually pick through, like say in here, we have like find all the function definitions and get me, things that have a certain number of parameters. This kind of stuff is really, really powerful because they actually are treating this code as data, and you can sift through it and get answers. This has got a lot of potential for really interesting security applications. And we get access to this simply by virtue of being on GitHub, but this is not an area where we've even really had time to go and look. So I think the thing to wrap up that sort of thought around GitHub is that there is a ton of data that's on there. It's really, really powerful. Everything on GitHub is fundamentally via this API is represented and available as data. And this, if you're on a quest to get everything as data, this is a very exciting thing. So for any security teams that are out there, if you are lucky enough to have a bunch of projects around you that are on GitHub, what this means is you have an incredibly powerful and valuable source of data that tells you what's out there and a lot of the details that help you decide where to focus. Of course, they need to be on GitHub first. So finally, the final stop on our little tour here is validation as data. So this one is kind of interesting. Security people have been telling developers for a long time that they need to kind of validate their inputs. But if it were actually as simple as that advice makes it sound, security would have been largely solved a long time ago. So this whole area has kind of been in a bit of a stalemate for a long time. But a new way of building APIs has actually brought some really interesting stuff that I think has opens up some really interesting possibilities in this space. So like I said, GraphQL is a way of building APIs. The concept here is that you define the types of data that your API will expose. And those types are kind of known collectively as your schema. Now, the types that you define then become the nouns and verbs in a query language that you give to your users to empower them to ask for the data that they need in whatever order and combination makes sense for them and their needs. The result from them running queries against your API is this like a response in just JSON format. So where this actually intersects with the sort of security stuff is here, and with this notion of GraphQL types. So the types, basically GraphQL gives you some really powerful ways to be very specific about what types of data that your API accepts. So say instead of having a sort of this vague notion of a string that you accept, you're able to, using the tools that GraphQL gives you, you're able to be way more specific and have specific types for postal codes, ISBN numbers, and social insurance numbers. The reason this is important for security is because being specific helps keeps malicious and invalid inputs out of your system. And this has some pretty obvious security benefits, but I think it's even more important in light of what I was saying earlier about dependencies, that, essentially if 90% of your system is these sort of open source components that you've sort of drawn from all over the place, that means that you actually don't have any idea how 90% of your system is going to react to invalid inputs. So it makes it really important to stop this stuff at the door. So importantly, like once you've defined all those types, the key idea here is that GraphQL, you can actually ask it for what types are defined, and it will give you that answer, and it will give it to you as data. So being able to ask a GraphQL what kind of inputs and outputs are available in this schema is a super powerful idea, because what it means ultimately is that GraphQL APIs make input handling auditable from the outside. And this is a new thing. So returning to our original sort of title here, this idea of like building for automation, hopefully you can see a little bit about what I meant here, in that, what we've done is we've changed the way we've built, to ensure that there's a whole bunch of automation possibilities that are sort of on the table. And interestingly, I think as we've done this, the thing that we've learned is that we're benefiting from some of the automation possibilities that sort of fall out of this approach. So our system is sort of reproducible, sort of in the business continuity sense. We're able to build the entire system again from scratch in about 10 minutes. And this has been done multiple times by multiple people on our project. Our system is auditable in a way that probably would be very rare in basically any system, in the sense that like every change to our system has just been edits to a text file. And so all of our system changes effectively are, basically trackable and attributable to individuals all the way back to the beginning of the project. On the security front, what this has meant is that we have fewer credentials in fewer places, and we've eliminated configuration drift. We actually know we can give you answers with confidence that they're reflective of reality. And for all of our operations stuff, it just ends up being better, safer, and faster. So that initial question that we were asking about, could we build trackers so that it can be analyzed? Well, the answer is way more than we thought. Basically, everything from service accounts to input validation is represented as data and visible from the outside. So what's interesting about that is that tracker kind of in its entirety is now ultimately data that can be used as input to some other process, perhaps some sort of analysis, perhaps by a future version of tracker. So I think one of the other things that's been an interesting possibility that's fallen out of this is it's hard not to look at this stuff, and think that what we're seeing is actually the ingredients for some sort of automated ATO process. With Kubernetes offering sort of 56 data types and configured connector offering another 91, what we have then is basically 147 different Lego blocks that effectively can be combined in various ways to build any system that we can think of. And we're only using 35 of them. So every one of these little bits of data just has maybe from 2 to 10 properties or something that are that's needed to basically answer any of the kind of security and policy questions that we might care about. So this is a really interesting area that is going to, I think, require a lot more sort of thinking and exploration, because there's some really powerful possibilities here. Now, as much as I'd like everybody to go out and sort of drop what they're doing and learn Kubernetes and config connector, it pains me to admit it that that's probably not that practical. What it could say here is that one of the surprising things is how much data GitHub actually brings to the table. And really what the realization is this is the biggest bang for the buck. So if there's just one thing you want to do that's sort of a low effort thing with a great reward, it'd be get your project onto GitHub. The underlying thing here is this is great for developers. The productivity boost and the collaboration has kept our little cross-department collaboration humming along nicely through all the COVID drama. And ultimately, if you're in sort of any kind of central security role, the data that this move would unlock is a really big boon. And importantly, GitHub just does vulnerability scanning by default. It doesn't even ask. So what you can have is sort of the confidence that essentially all of the projects that are on GitHub are being exposed to this sort of evolutionary pressure of constant vulnerability scanning and notifications that is really helpful for kind of raising the bar for security across the board. So to wrap this up, I definitely want to say that, I think we as the government of Canada really need experiments like this. I mean, we were going to build this system anyway, but to build it in a little, experiment with the approach and build it in sort of an opinionated way that sort of allows us to sort of explore some possibilities. I think this is really important because there's a whole bunch of services that need to get created. And shipping stuff shouldn't require accepting a ton of risk. And finally, I think we specifically security need experiments like this. There's an oft-cited ratio within the industry of 100 developers to 10 ops people to 1 security person. And that is a pretty stark structure to kind of have in the background of your mind when you're kind of doing your work. And so I think the realizations that come out of this are really that, efforts like Tracker are really important. And they're important because ultimately this effort to make security visible empowers everybody to work on this problem, and to tackle this together is exactly what we're going to need to succeed. So with that, thank you.